Bismillah ar-Rahman ar-Rahim. Assalamu alaikum everyone. So this particular lecture is a lecture that I usually teach all of my classes, and this is partly because this is, you could refer to as going back to the drawing board per se. Now in this particular lecture we're going to talk about principles of visualizing data, a lecture by Stephen Skeena of Stony Brook University, and we're going to talk about again practice of data visualization. Now both these lectures are available online at cs.stonybrooks.edu. Now these are the 25 formal lectures that he teaches for a course by the title of Data Science. And the reason why I teach these courses, especially this course, is because we are going to is really because what we would be doing now is we would be doing an assignment where you would be given tasks directly related to this lecture. Now this lecture is divided in two parts, and part one is going to be about 20 minutes long, and part two is also going to be 20 minutes long. If there is a need, they will go for part three, but let's see where it goes. Now this is where we're going to look at how you can present data in a graphical manner so that it is presentable, readable, and fully understandable. Now, the first thing which is absolutely important is to look at your data and figure out if it makes sense, if there are any patterns in the data, and is the data relevant. Now it is extremely useful to visualize the data before you use it. Now that is called exploratory data analysis, and it's really useful to visualize your data and see if you can see any patterns, or you can see things which otherwise you may not be able to, or it will take too much time for you to see. So for instance, let's look at these four data sets. Now all these four data sets have the same mean, have the same median, and have the same variance. Now if you look at the bottom of these three, you can notice X has the same mean 9, 9, 9, 9. Y has the same mean 7.5. The variances of X and Y are the same, and the correlation of X and Y are the same. Now if you take any four data sets and you try to figure out their mean, variance, and correlation, they would show as if they have the same properties. However, when you draw them on a graph, this is what they look like. What is interesting, that all of them even have the same regression line. Now the only regression line, or only data that fits the regression line, is the first data set. The second data set actually looks more like a curve, so linear regression shouldn't be applied here. The third data set has a skewed, the regression line does not follow the data set because there's an outlier. And this outlier should have been removed prior to making any of the evaluations of mean, variance, standard deviation, and in attempt to make the regression line. If you look over here, you can see the entire data set is skewed over X is equal to 8 lines. So X8 is fixed and Y varies from 9 to, let's say, 5. The only reason this line is skewed in this way is because there is an outlier. So if you remove these two outliers, the regression line would look extremely differently. Same goes for here, in that linear regression should not have even been employed. So if you look at this 4 data sets again, all of them have the same mean, the same variance, the same correlation, and the same regression line. Well, when you draw them, they look very different. So visualizing data is necessary. Now when you look at art, it does take, and through this lecture we will help you develop a sensible appreciation of art by looking at what's important and what's not. So the 4 primary items that we would discuss is the maximizing of data ink ratio, minimize the lie factor, get rid of any chart chunk, and use proper scales and clear labeling. Now as an example, let's look at this. Data ink ratio is how much data you're presenting divided by the total ink used in the graphic. Now if you look at these 2 images, they present the same information. However, this one is better than this one, is because this one is using less ink to present the same amount of data or the same amount of information. In fact, both of them are even histograms. So having this 3D image doesn't really help. It's not adding more value to your presentation. So the whole point is to maximize this ratio. In other words, you should present as much data as possible by using as less of ink when you print these images. The other very important is reducing the lie factor. Get rid of it. Now if you look at these, if you look at, for instance, this particular image, now it shows the price of barrel from January 1 to April 1. Okay, or actually it also shows the years 1973 to 1979. Now what is important here to see is that when you visually see this, it seems what you're really focusing on is the entire area of the barrel, the area occupied by the barrel in relation to the whole diagram. Now, to be honest, 13.34 in relation to 12.70 is not significantly higher. But if you look at the barrel, it is significantly larger than the one here. So although they are not lying to you per se, they are quite true, they've shown the values here. But by showing these barrels, they are giving a false psychological increase, which is significantly larger than the actual increase in the price. Now, if you look at the same diagram here the effect is more pronounced. It shows the percentage of doctors devoted solely to family practice. Now, if you look from 1964 to 1990, they've shown the numbers here, so they're not lying to you. But what they're really showing is that this is 27, this is 12. What you focus on is the area covered by the medical doctor and not the percentage. Now, if you compare 12 with 27, this guy, in terms of the area covered, is not twice as large as this guy. He's only almost 3 or 4 times the area covered by this guy. So the percentage decrease is not 12 and 48%. It's 12 and 27%. So technically, they're not lying to you. But what they're doing is the psychological effect of the graphic is significantly larger than what actually is presented in the data. And that is something that you should be careful of, not to get yourself blown away with this. So this is an extremely important diagram. In this diagram, you do see a sense of graphical integrity. Now, as a precursor, there are two main political parties in the US. One are the Democrats and the other are Republicans. President Bush was a Republican, Obama a Democrat, Trump a Republican. Fox News is highly pro-Republican. Now, what they're showing here in their TV channel is that if Bush tax cuts expire, so he has presented some tax cuts, what happens to the rate of the tax if you remove the tax cuts? Now, they are true. They say, well, this is 35% and this is 39%. So if you remove the tax cut, the tax is going to jump. But notice how big 39 feels in relationship to 35. If you simply look at this diagram, it shows that this particular cut is significantly larger than this. In fact, if you stack these up, it's 1, 2, 3, 4, 5 times the effect of this guy. But here's the thing. Notice where the graph starts from. It starts from 34, not 0. But if you look at the same diagram here and you scale it to 0, now you realize, well, there's not much of a difference if you look at the complete scale. So this is 39.6% and this is 35%. So for graphical integrity, or for a scale, to be honest with your scale, you should start from 0 and always label your axes properly. This is another thing which is called an aspect ratio. Now the aspect ratio, now all these three graphs are exactly the same. Now which one is better? It depends. Now if you are, for instance, which one would be used by which one? So if you are, let's assume these are your profits and see how they fall as the months go by. Now if you are if you're a manager who's been hired and you show your progress to board members, maybe this is the one that you show, that as the months have passed, we had stable growth, but here something happened in August and the growth fell considerably, but now we are going back up. If you really don't like your company and if you want to get rid of someone, this is the graph that you would show, and you could show, well, we were doing fine, but now you can see there's a huge decline in profits and we need to get rid of this guy, otherwise we won't be able to reach back up again. The best, however, is to maintain cliffs and troughs which somehow aim for 45-degree lines or 45 degrees. So this is, if you plot this, this is approximately 45 degrees from the top till the bottom. And the aim is to, this is better, or you could say this is the middle way. Now it also falls, either it could be 45 degrees or it could follow a golden ratio. Now I would recommend you search online what's golden ratio. It is an interesting observation that the golden ratio is one of the most highly used ratios in nature. Now looking at the same scale of proportions, if you look at from 1978 to 1985, what this agency is trying to show that the fuel economy standards for autos have improved. So the fuel economy standard was 18 miles per gallon in 1978, now it's 27. But notice, and the road shows how far we've come. But here's the important thing. If you compare the graph on the left, 18 is only this much. Now if you plot 18 in relation to 27, you get 1, 2, 3, 4, 5, 6, 7. Because you're focusing on what is being showed to you. Now, it looks as if this number in 1985, they've improved 6 times. That's what they're showing. That is not true. They haven't improved 16 times. They haven't even improved twice. They've technically more or less improved by 50%. Now that's not weird, because from 18 to 27, it's a little above 50%, but it's actually exactly 50%. But the point is, what is shown here is 6-fold improvement, which is not true. But if you see the graph here, now here the scale starts from 0, and 18 and 27.5 don't seem very different. Yes, you see an improvement, but it isn't 6 times as is presented here. So the question is, can this be the same data? The fact is it is, but there is a lying factor here which is not visible here. The other thing is to reduce chart junk, meaning get rid of information which does not help you present your story. Do not use excessive grid decoration or useless coloring or dimensionality which does not add value to what you're telling. Given an example, let's look at this. Now, I don't even know what this graph even is trying to say. I have no idea what this graph is trying to say. There are just too many colors here, and it's just I don't even know. Now, as an example, a good example, let's look at this plot. Is there any way you can improve this plot? Now, one thing you could do is remove things which do not add any information. Remember the first topic or the first element that we discussed. Improve data ink ratio. So the first thing you could do is you can get rid of this blue background. This blue background is not adding any information to your plot. So from this, you end up here. Sorry, the first thing he did, he got rid of the extra grid lines, right? That's one of the first things he did. He got rid of extra grid lines. So this is how it looks like. It is a significant improvement. Now you get rid of blue, this is what you get. The other thing now you can do is, now compare this diagram with this. It is significantly better. But can you simplify this further? Well, yes, let's try to get rid of unnecessary boundaries. So this is what you end up with. Now, is there anything else you can do? Well, yes. How about if you draw, we do need this. I mean, it's worthwhile to have you have a grid here which goes all across. But rather than putting a line, let's get rid of one. So this is what it looks like, right? So normally people draw a line. Here we've removed it. So you have the same 10% which is going across, but you don't see it. You don't see a blackness going across. Now compare, and this idea of less is more, compare this with this, right? See how the transition is unfolding. The plot is the same, but now you can focus more, and it looks nicer as well. So there is a matplot library. You can forget about this right now. Actually, no, sorry. In this course, you do have a matplot. MATLAB has an excellent plot library that you can use. Even Python, which is a programming language, very useful to learn, also has a matplot library. So you can do very good plotting in Python language using the matplot library. Which chart should you use? Here are some suggestions. As you can see, there's a huge load of different types of graphs you could use depending on what is it that you want to do. So if you want to show relationships or distributions, you have histograms, scatter charts, 3D area charts. If you want to do comparison, you can do it over column chart, line chart, circular area chart. It really depends on what is it that you want. Here are some suggestions of which plot you can use based on what are you trying to showcase. Another thing about tabular data, so now moving away from graphs, let's talk about tables. Tables are useful. They're very useful in explaining things. So let's look at this table. Can you improve this table? Now if you look at this table, it shows a number of important elements. Actually, it's about 20 minutes. So let's stop here and we'll discuss these tables in the next lecture. Thank you very much. Assalamu alaikum.